Hey everyone, it's Alan Schimmel, editor-in-chief, founder of MediaOps, the people behind DevOps.com, Container Journal, Security Boulevard, and others. Thanks for joining us on another great webinar. I think we're going to have a really good webinar, especially for my cloud native fans out there, Kubernetes users, security people who are confronted with securing Kubernetes infrastructure. This is really one of the best webinars you're going to probably attend in the next year, I would think. The title of the webinar is Kubernetes Security Best Practices, and it is through our sponsorship and friends at StackRox who are presenting today, and many thanks to them for their expertise and working with us. Before I jump into the webinar, though, I wanted to just take a moment and go over some housekeeping rules. Here at our MediaOps, DevOps.com webinars, we use the GoToWebinar webinar platform, as you can probably tell. For many of you, you have your GoToWebinar control panel probably in the right-hand corner of your screen or somewhere in there on the screen. If you look at that control panel, I'm going to direct your attention to two specific areas I want you to key in on. One is marked questions, and if you can kind of click the little arrow or caret next to questions, you'll see it expands, and you can see that you can type your questions in there. We could answer them in real time. Your questions are automatically queued for our questions and answer session that we've made time for. And it's really great because if you're anything like me, a great webinar like this, you're probably gonna have 3, 4, 5, 6 questions, and you're liable to forget the first one you have by the time we get to questions. So don't wait till the end to type in your questions. Put them in real time. This way they're there. And as I said, if it's something that we're not going to do in the context of the whole group, we can even answer them privately for you. The next section I want you to focus in on is the chat section, which is at the bottom. For our webinars here at DevOps.com, we use chat for technical support. Please don't ask questions regarding subject matter. Put those in the question section. But if you have a problem, the slides aren't advancing, the audio is choppy, some other sort of technical issue, we do have GoToWebinar engineers and our MediaOps support staff on hand who will try to help you. And if you can type in your question in there or type in your issue in there, we will try to remedy it as quickly as possible. But again, subject matter questions go in the question section, technical issues go in chat. Let me answer the first question for everyone right now, and that is yes, this webinar is being recorded. Yes, it will be made available, usually within a few hours of our concluding this, in about an hour or so, and you'll be able to watch it on demand. So even if you do have issues, you'll be able to watch the webinar on demand if for some reason you're not able to join us. With that being said, one other thing I want to mention, we're going to be doing some polling questions here today. Polling questions are great. I personally love them on a webinar because it gets you, the audience, involved. But they're only as good as your involvement. So please answer the polling questions. They're basically multiple choice, ABC kind of stuff. If you answer the polling questions, we understand where you are in terms of your Kubernetes security issues and challenges, and it gives our speakers a better flavor for what they need to focus in on that's going to help you. So answer the questions if you can. I know it's easy to just sit there and let the next guy do it, but those questions are only as good as your involvement. So please join with us in that. That being said, let me now turn back to our webinar. As I mentioned, it's sponsored by our friends at StackRox, Cloud Native Security. They will be at the RSA conference next week, and as will we. So if any of our listeners out here are planning on attending RSA conference, check out the StackRox booth. And I don't know, maybe someone there knows our booth number. And you can also check out DevOps.com and MediaOps on Broadcast Alley in Moscone West. With that being said, though, let me introduce Connor Gorman, who is our principal guest today. Connor is also a principal engineer at StackRox. In that role, Connor designs and builds the StackRox Kubernetes security platform, or helps design and build it. And he's really focused on helping users understand the complete risk context for Kubernetes workloads and enabling them to implement effective security controls to mitigate the risk. Prior to StackRox, Connor was a key person over at Medallia's worldwide data center and application deployment architecture, where he really helped to design that. So Connor, welcome to today's webinar, and thanks for presenting.
Thanks, Alan. Thanks everyone for joining.
You gave me a scare there for a second, but all good. Before we turn things over to Connor, though, let me introduce a very special guest. This lady and I know each other a long time. We're not going to say how many years, though, but it's more than a few. Michelle McLean is currently VP of Marketing, I believe, at StackRox, but Michelle has had a variety of roles and positions over her career in cybersecurity, involving both engineering, marketing, business. Probably one of the sharpest people you're going to meet that I've had the pleasure to meet in the industry in the 15 or 20 years that I've been in the industry. So, and I kind of twisted her arm to appear today with us. I apologize that she's not on the landing page for this, but I think it's a treat to have her. Michelle, welcome.
Thank you, Alan. Always a pleasure to be with you again, my friend.
All right, Connor, with that, I hope we didn't put too much pressure on you, but we're going to turn it over to you here, and let's see what we've got on Kubernetes security best practices.
Awesome, thank you. Thanks everyone for joining. Yeah, as Alan mentioned, I'm a principal engineer at StackRox. We do Kubernetes and container security, so it's right on topic. We're going to be talking about Kubernetes security best practices. Cool. So what we'll cover today, we're going to talk about general Kubernetes hygiene, around the orchestrator itself, workload best practices, which I think is a lot of the bulk of some Kubernetes security. We'll go through a demo because listening to me talk can be really boring, and then I'll answer any questions you guys have at the end. So what are we doing here, right? Kubernetes is coming. Many of you are at a large different variety of your journey, right? You're either having it be pushed in production and you're having to deal with that. You're maybe pushing it at your organization, or maybe you're thinking about it, you're seeing everyone go there, and you want to get there yourself. And so it's not really coming, it's pretty much here. Looking at all these trends over the past 4 years, basically the number of people searching for it has increased exponentially. The number of KubeCon attendees is getting up there with AWS. And the cumulative growth of contributors really shows that it's a whole ecosystem and not just a couple companies sponsoring it. And so what we want to do is we want to jump to a poll real quick and see what describes your role and when it comes to Kubernetes security, and why are you interested?
Okay, let's, as I mentioned, answering these questions really helps us, but we don't have all day for it. We'll close questions off in 5, 4, 3. Come on, only half of you voted. Votes. Let's get some votes in, guys. 2, 1. All right, let's close voting.
Awesome. Cool. So a lot of infrastructure operations, DevOps folks. That's awesome. I know that that's a huge concern, and that you're worried about security and what that means in the Kubernetes environment, especially as you guys are operationalizing across your infrastructure. And I think a lot of times DevOps and security, when it comes to Kubernetes security, really need to work closely together, because it's kind of like a mesh of a subset of expertise. So again, thanks for all for joining. Let's kind of jump into it. So basic Kubernetes. Sorry.
Connor, I just wanted to mention, I'll ask Michelle as well. It's not unusual that we would have so many more sort of DevOps Kube experts rather than security people, and that's probably part of the problem is we don't have enough security people. Michelle, is that something you guys see across the board?
It really is, and we go out to our audience, our customers, and the people that we talk to on a regular basis and ask that exact question a lot. Who's going to own securing this infrastructure? You know, and Connor, as a developer, is bringing that experience of being the person driving this infrastructure, and you just can't separate out the security of this infrastructure from the running and the building of this infrastructure. So we see over and over again in our findings as we're interviewing people and surveying people who's going to own this, and it's very squarely falling into DevOps routinely. So I just think security is so intimately related to this infrastructure. You can't like build it and then, oh, I'll do security later and I'll layer it on top. Like that's just not how it works in this infrastructure. So I think that's why the people doing infrastructure ops, DevOps, are the ones driving the security for the stack itself.
Excellent. Connor, I'm sorry. That's what you get for inviting Michelle and I. Go ahead.
No problem.
Not that he invited us.
Cool. So let's jump into it. This is an obvious one, but one that always needs to be said. Upgrade to a current version. You know, for infrastructure folks, we don't like scary events. We like to plan things out. We like to make sure that things are rolled up, you know, over time and correctly planned, especially when it comes to infrastructure. And so Kubernetes maintainers have supported the last 3 versions, which is right now 1.17, 1.16, and 1.15. If and when a security vulnerability shows up in Kubernetes that's super critical, that can be exploited easily, right? You want to be able to upgrade quickly through a patch release, right? You have a lot of confidence that a patch release should have minimal impact on your environment. The last thing you want to do is be stuck in a situation. I don't know how many of you guys remember the etcd2 to etcd3 migration. Like the last thing you want to be doing is doing a major infrastructure upgrade in order to try to patch a CVE and rushing it at the last minute. And so keeping up to date within that sliding window of support is super important and super critical and lowering the risk. I mean, you also pick up things like deprecations. In 1.16, extensions v1 beta 1, which is a lot of people were using for their deployments in other objects, is deprecated, and you don't want to be trying to roll all of your infrastructure as a part of an upgrade for any particular reason. I will say that some cloud providers do patch older releases. I think the default on GKE right now is 1.14. Google is pretty good about patching their releases with vulnerabilities. So you might have some coverage there, but kind of like your mileage may vary, and make sure you really understand what the posture is of your orchestrator and how you can make sure you're always staying up to date. One major thing that I, as an ops person and a developer, that I find difficult is keeping up to date with all of these things, right? You might be using a lot of different software. It's upgraded a lot. There's a lot of changes. I personally love this Kubernetes announced Google group. It gives me all of the live updates. It's not too busy, sometimes it's a little busier than I'd like, but not too busy. And basically it'll let you know when new versions are announced. You can go look at the change logs, see if anything impacts you, new patch releases, and definitely for, vulnerabilities like the bottom one on the screen there. Basically malicious YAMLs and payloads could DDoS your Kubernetes API server. So that's from like more of a management perspective. It's like, let's make sure that we understand what's going on and how the ecosystem is changing. And then kind of like on a more practical sense, right? Let's apply some of the best practices that we've been applying to infrastructure for forever. Let's control network access to the sensitive ports in Kubernetes, making sure that we're blocking ports used by the kubelet, right? And definitely consider limiting access to the Kubernetes API server. The last vulnerability I mentioned on that page before was basically someone anonymous could DDoS the Kubernetes API server. If you restrict that to trusted networks, then only someone within your trusted network could DDoS that Kubernetes API server, right? The whole service area there has been completely decreased. And so, these are just the best practices we've been following forever, right? But let's make sure we still apply them to a Kubernetes environment. They're still very relevant. Right, and this is another kind of no-brainer sometimes, but let's make sure we limit access to the nodes within our cluster, right? Debugging and other tasks can be handled, without going to the node directly. Anyone who has access to the node and Docker, right, has access to Kubernetes. You can exec into pods, you can, run a whole variety of commands, and you can use distributed tracing, distributed logging to help users debug without having to grant them actual physical access. So, along the lines of access, right? We scoped our Kubernetes API server to in-house. We restricted node access. Let's restrict access to the Kubernetes objects themselves. A lot of times what's happened is that someone created a cluster to POC Kubernetes at their organization. It was really successful. It keeps moving forward. It gets bigger and bigger. but they have left old roles and bindings that they gave to a previous admin, never intending it for this to go into production or even in a lab. And so they have a huge scope of resources and API capabilities. So they might have cluster admin on the cluster, right? And so the way that Kubernetes breaks down RBAC, you have subjects, which is a developer or a user. It like can be binded to service accounts, which are have the ability to access the Kubernetes API. You have all the API resources. If you ever run kubectl API resources, you'll see Kubernetes has a ton of options. And then finally, what they can do with those resources, right? And so let's really make sure that we audit this every now and then. Make sure that we're not granting, over granting access to a developer, or granting them access to get them started and then being able to scope it down over time and really understanding what they're using. So this is kind of wraps up what I feel is like general Kubernetes hygiene, which is how do people access the system? How do we restrict that access? And how do we make sure that no one can go to the nodes and tamper with our services or have entry points? I think workload best practices are a huge section of Kubernetes security. And I think it's one that security folks feel like they have the least insight into. Developers are pushing code through CI/CD. It's being automatically deployed to Kubernetes, right? And kind of where does security come in, and how can we leverage the best practices there? So first and foremost, and something that I like to think about a lot is contextualizing risk in Kubernetes. And there's a lot of different angles, right? So it starts with the image that you build. It can have vulnerabilities. It can have packages that could be used by an attacker. It could come from a registry you may not trust, right? Docker Hub is a great service, but I wouldn't trust everything in Docker Hub, right? Just like you wouldn't trust anything in an NPM registry or Maven, for example. What cluster you're running in, what's the environment, what data is there, what is the configuration of your service? Is it privileged? Does it bind host mounts? Does it have access to the Docker socket? We were talking about service accounts a couple seconds ago, but what access to the Kubernetes API does it have, and how could it impact your overall environment if someone were to infiltrate that specific container, right? Does it have access to secrets, crypto material? Is it running on PVCs that has a lot of your data, right? And so kind of like, what is the configuration of the specific service in context of the image, right? And then you kind of go into how you look at, actual activity of that container. If this container or pod were able to be breached, what would be the blast radius? And how could someone infiltrate this container? So, internet reachability, is it on the internet? And then kind of like once you get into the post-breach portion is like what processes were launched, what connections were made, do those look anomalous, do they look correct? And so this is how I think about risk. And actually we have an interesting poll about where you are in Kubernetes and your security around that. And because there's a lot of different angles, and so we're always super interested to know.
And while we're running this poll, I'll just make a quick comment. We've been getting some questions offline about being fairly new to Kubernetes and where do we go to learn. And there's lots of resources, and we'll follow up with folks afterwards with some key resources to get up to speed. I think one thing that's really important to keep in mind that Connor makes sound, very obvious when you look at what can you learn from Kubernetes that informs risk. I think the thing to think about for those of you maybe newer to this infrastructure is that while it can feel a little overwhelming and there's a lot to learn and there's, a lot of security stuff isn't enabled by default, all of these challenges, I think the thing to be really excited about is that this is really the most secure, like we have the opportunity to build the most secure apps we've ever built using this kind of infrastructure. That rich context that Connor just outlined, that's unique. That you could understand all of these aspects about your environment and evaluate and understand risk with that much clarity and that much certainty, that's new and it's cool. And we have a lot to learn. We have a lot to work through to how to take advantage of that. But we really are sitting at the forefront of being able to truly build so much good security directly in the infrastructure. And it's exciting, this big change.
Absolutely.
Thanks, yeah, I think that's a really good point. And
okay, I'm sorry, Connor.
Yeah, I think it's a really good point. I think now more than ever you have more knobs to turn. I'll give a demo of some of those knobs in a little bit, and we can talk about some of the stuff that really wasn't possible in a pre kind of Kubernetes environment that you can start using and like you can really lower the attack surface of your applications and feel way more comfortable running, like, you know, running Kubernetes in production, and the granularity you have has never really been had before.
Excellent. So the question's been up a while, or almost 2/3 of the people answered. Here's our survey answers. Connor, what do you think?
Awesome. It's really evenly split. I think, you know, this is something that we've seen a lot at StackRox, is that people are at all different spots in their journey and all different roles within that, right? So, you know, image scanning is a big one, right? Let's make sure that what we're deploying to production, that we have an understanding of what we're running and the vulnerabilities that are there, right? Configuration management is like, how is your service configured, and are they configured correctly, right? And kind of like the new wave is developers are configuring their services for production. And so I think that's a concern, because, you know, developers don't do it maliciously, but they may not know the proper configurations, and they want to get their applications to run, and they might not be using the best security practices there. Network segmentation is huge, of course, like firewalls, you know, have been a big business, and bringing that to Kubernetes is also awesome. And then compliance, you know, everyone's concerned, SaaS and cloud native companies, you got to have compliance, you need help with audits, and you want to make sure that your new environments are also compliant, just as your old environments are. So I think all of these concerns are super valid and stuff that definitely needs to be addressed within a Kubernetes environment. If you have none and you are in production, you know, we got to get, you know, yeah, and you don't have to tackle all of these at once. I would say, hey, like let's start tackling these, you know, systematically. I think the idea that you have to have everything or nothing is not correct, and you can, you know, start with image scanning or start with network segmentation and really build out a security platform for your organization. And so what we'll jump into now is kind of like how I like to think about and contextualize risk, and what some of this means. And so, you know, if you look at the kind of the right-hand side, is that we got a specific deployment that we're looking at, and, you know, there's a huge number of components that go into the risk, right? And there's a lot of angles and ways you can slice and dice the data that, you know, you may not have had before, but now you have access to Kubernetes API, you have access to, you know, runtime data, you know, pod replication, right? And so what you're looking at here is that, you know, you have policy of violations, right? You have a policy engine that you can run, and this is like your organization's goals, right? You put, what does your organization care about and really want to avoid, right? And that totally depends on what you're running and the policies you want to create, right? Suspicious process executions are, you know, analyzing runtime data, looking for anomalies. Image vulnerabilities, right? Those are obvious entry points into your cluster, right? Things get a little bit more interesting with service configuration, service reachability, right? If you've got something that's really heavily segmented and it's behind, you know, 3 layers and not exposed on a load balancer, right? It inherently has less risk, right? If something's on the internet, a high vulnerability, and you're seeing suspicious processes, really you got to go take a look, because those are huge areas of risk for you, right? And the number of images and components, image freshness, RBAC configuration is, you know, if someone were to breach this, where can they go with it? And, you know, what tools could they use in your image, and what access would they have to the API server? And so this is just like a couple examples of ways that you really want to think about risk in your environment. And it's really multifaceted. It's not really, you know, just focusing on image vulnerabilities doesn't tell you the whole picture of, maybe you have really great network segmentation and that is buried somewhere in your cluster that, you know, no one can really jump to. So I think that's a really important thing to look at. So cool, I talked about how all of this risk exists in your environment, right? And the real question is, how do I reduce the risk that exists in my environment? And so first and foremost, leverage namespaces. It's great for resource usage tracking from an operations and infrastructure perspective. It allows RBAC to be finely tuned. So, you know, maybe you have a namespace for operations, and they can access things within that namespace, and they have, you know, can create pods and delete pods within that namespace, but they can't affect other teams. This is kind of a nice team-based segmentation. It allows for really generic network policies and network segmentation, which I'll go into a little bit more. And then also, like, for me, it makes kubectl results more sane. I don't know if you've ever tried to list pods in one default namespace and you see 1,000 results and you can never find what you're looking for. But just the natural segmentation into namespaces, which are, you know, generally the way I like to break them down is, what does this do? right? And what team does this belong to? And then that can really help you kind of figure out like what your environment looks like in different spots in your environment and who's operating within it. Also, leverage network policies. Leverage the native network segmentation that's built into Kubernetes. Basically what network policies are, for people who aren't familiar, it's basically what I consider pod-centric firewalling. It's pod A can or can't talk to pod B. Generic policies on ingress and egress can really help ensure fine-grained connections. I'll go into that a little bit more, but basically you can say, two namespaces can't talk to each other. If you're running a SaaS multi-tenant environment, this really helps with compliance to ensure that, two customers' data cannot be possibly mixed together. And everything else, from a monitoring perspective, needs to be exceptions against that. And, these sound great, and it sounds like really awesome tools, but there's some distinct challenges here, which are, what if my environment already exists, right? What if you're already running in production? How do I go apply firewalls without breaking production? How can I scale network policies at my organization? And how do I make sure that developers aren't able to build their own network policies? Because that's really truly the way that you make things scale within an organization, is that it's not security's job to build everything, but it's security's role to work with developers so that they build their own security out of the box. So these are really important aspects, and kind of like on a funny story note, and something that we've built here at StackRox because we find it really important, is that I was trying to build network policies a couple of years ago. I couldn't do it. The YAML files are really, there's a lot of idiosyncrasies between them, and I was basically unsure whether or not what I was doing was working. If you use brackets or don't use brackets, it has different meaning. And so it was really tough for me to figure out what was going on, and I was basically execing into pods, running curl commands, trying to see if I had properly done it. And so I talked to our product team, like, hey, we should help people solve this problem. And so what we've done is we've created a graph so you can visualize it and see the connections that are existing. One from an active perspective, so looking at the live traffic, seeing what can talk to what, and then also showing the allowed traffic, which is basically a rendering of network policies live on a graph, allowing you to simulate network policies to understand if you are going to break production and let you know that you are, and then also finally just generating the ideal graph for you, which I think takes a lot of the stress out of generating network policies. Is, okay, I'm taking all the live traffic, I'm implanting it, and we've got some logic that will build this for you. And so I think this is one of the, in my opinion, one of the coolest things we've built. And so this is really important.
This is perfect segue. I've been holding on to a question here from one of the attendees around trying to validate YAML files and the challenges of that. And one of our other solutions engineers likes to joke, pull up the YAML file, get out your ruler, look at your indent, did you get it right? So I think, Connor, having lived this pain as a developer and then bringing that into the product, the whole goal here is there is so much potential in the infrastructure, like we talked about. We can build the most secure stuff ever, but have we built it right? And so having a set of recommendations, best practices, guidelines, guardrails for developers that are native to the platform and built into the tooling so that you're not guessing and you're not trying to find that needle in the haystack about where did you miss something, where did you get something wrong. So this network graph, I think, is a great example of that, because YAML files are a great place to get things wrong.
Yeah, exactly. And we're talking about configuration management, right? And your organization's created a set of policies. The last thing a developer really wants to do, like myself, I don't want to push it into CI, wait 20 minutes, get a result back that it couldn't be deployed because it violated some policy, right? What I'd love to do is say, I built this YAML, I built this image. Let me post this against some service that tells me, hey, by the way, you're running as privileged. There isn't an exception for this specific application, and it's going to be rejected, right? And you get that instant feedback. Same thing with an image. Oh, hey, by the way, you have a really critical vulnerability. Obviously, I'm not trying to build something that has a critical vulnerability in it. And so, especially, and the big thing for me is actionability, especially if it's fixable, right? If it's a fixable vulnerability, there's no reason for me not to go fix it. And so having that instant feedback, I think, is really important in terms of having security and operations mesh, and really enabling developers to kind of use security best practices. I mean, you have to enable developers to use these tools because, they're the ones building all the code. And so it's the best place and the most efficient place really to to inject this.
Yeah, and there's so much research around the earlier you do it in the cycle, the better off it is. The faster it is, the more secure it is, the cheaper it is, you come out to a better result, you have a smaller attack surface from the beginning, all of that. So that's probably the hardest thing for people to get in their mindset when they shift from traditional ways of doing infrastructure to more DevOps approach and more cloud native stack, is that it's coincident from the beginning. Security and building are coincident from the beginning. It's not a waterfall anymore. We don't wait, and we don't certainly wait. Well, sometimes we do, but we try not to wait until we're in prod. Oh, I built it one way and it was fine for dev test, but now I'm going to go to prod, so I'm going to rebuild it and build it securely. That's so anti-DevOps. So don't do that. Build it right from the start, and you're not going to get everything right, so look for tooling that can help the developers without a human being there saying, oh, you missed a little thing. Here it is. Go do this right.
So if I could jump in, if you don't mind, guys, I think one of the primal lessons we're learning in DevSecOps, though, and it goes to something Connor said, which is, hey, we've got to build these security tools for the developers to use. Well, part and parcel of building security tools for developers to use is they've got to be sort of developer friendly. Don't assume these people are going to have that security background, right? They may not know from zero trust kind of, blacklist, whitelist. They're not thinking along those lines and stuff like that. Connor, you come from a developer background, right? And so I think the key for us to really turn the light switch is put tools in the hands of developers that they can use, that they don't look like and say, oh geez, this is a security guy's gal's tool. I don't know what I'm looking at, right? And I think when we do that, we're gonna just set this thing up to really, as you say, Michelle, be the most secure platform we've ever developed on.
Yeah, I think generally developers don't like to be told what to do without a reason or a thing that they can do to fix it, right? And so even looking at vulnerabilities that aren't fixable, right? I mean, there are tons of vulnerabilities every day. I think NVD has over 100,000 right now. And if they're not fixable and they're not high risk, there's very little you can do about them. And so really focusing on the ones that are fixable and the ones that developers could go fix. And then giving a reason why, right? Telling the developer, hey, here's why you should care. This is a really high vulnerability. It can be accessed over the network. Your service is on a load balancer publicly. We should go fix this. And I think all developers would agree with that. Now, if you just tell a developer, go fix this, the reaction is not going to be the same as giving the reasons why and understanding, letting them understand, hey, for our organization, this is not something to have. And so that segues kind of directly right into this one here, which is slim down your images, right? Go distroless or use lightweight base images. You'll remove a lot of extra packages and bloat in your image. You can remove package managers after you're finished using them. At the end of your Docker file, go ahead and remove them. And you can remove network utilities that aren't used live. You can remove file system modification utilities, chmod shown, right? A lot of times you're not actually changing the permissions or ownership within the actual running container. And then finally, scan it and enforce to prevent them from entering your environment again. I think compliance is a continuous process, right? Contrary to a lot of things that are we run one scan, and then we see if we're compliant, and then we try to go fix those things and hope someone didn't introduce something new. But you can create and enforce policies so that once you've gotten to a good point from a compliance perspective or a hygiene perspective, then you can enforce that you're going to maintain at this level. And I think that's a really new thing too, is being able to say, hey, let's stay at this level of compliance. And so when I do have an audit, there's a magnitude less things that I have to go fix. And I need to bug developers, in a very bursty fashion, but more, it's a continuous process that's now built in. The major question here though is, how do I debug?
So let's get to that. I just want to call out, there's a bunch of questions here, and I'm putting Connor on the spot because I haven't figured out what he's going to want to speak to. There's some questions about starter information. We're going to follow up with you guys offline on some of that because we have a lot of folks on the learning curve, which is awesome. There's a question around observability, and there's a lot of focus on observability, but I think there's two parts to that. One, how do you get from observability or seeing something to being able to act on it? And I think you've talked about that. It's things like hey, there's a problem here is one thing, but here's what you need to do to fix it, and if you make this change, your build will be successful, that kind of thing. And by the by, having that information where the developer lives. So even if you have secondary tooling, even something like StackRox that is looking at things, making an observation, that information needs to come back into where the developers live. They're living in CI/CD. So that alert, that flag, that failed build needs to show up in the developer's pane of glass with the remediation, with the rationale, with what they need to do to fix everything so that they can build successfully. I think that's one piece of it. But this person's also asking, if you have security somewhat locked down on a cloud distribution of Kube, can you bring that into on-premise? Is there a way to kind of clone those instances while keeping security integrity? And I would just make one comment broadly before I turn to you, Connor. Your pain is, we really see that pain a lot. Most of the customers that we're talking to are doing hybrid, and there's a lot of power in hybrid, but there's a lot of challenges in hybrid too. And so one of the choices that we made architecturally was to be really deeply integrated with Kubernetes, because Kubernetes, just like it's your universality layer, it's your portability layer at the infrastructure level. If you have security tied to Kubernetes, you get that same extension and portability and universality, cloud to prem, environment to environment, with your security policies, just like you got with your infrastructure control. So that's one thing to think about if you have to manage a hybrid environment, is if I tie in at the kube layer, rather than like sporadically running random controls against individual containers, then I can get that policy construct, all of that stuff to follow my environment. Is there anything else that you'd point out to somebody that's looking to port cloud to prem?
Yeah, I mean, I think just like try to understand where your interface is, right? And so like when I think about moving stuff from different clouds or running EKS, GKE, right? And like we support all of them, so we live this. But basically that, Kubernetes is a layer that provides a set of abstractions for you, right? And so when you can utilize those abstractions for security or monitoring, right? I'm mentioning monitoring here, right? You can, running Datadog as a daemon set, right? Guarantees that it's going to run on every node, regardless of what cloud provider you're in, right? And so and that's kind of the power there. It's like I can take this whole thing and put it somewhere else. I mean, of course, you're going to have to deal with, they have different block storage, they have different, metadata storage, GCS, S3, cloud buckets. Like there's always going to be those within the difference in the cloud providers, and I think sometimes, that's how they kind of get you locked into some of them, is that you're really heavily relying on those. But in terms of like a Kubernetes layer, those are it's a pretty generic layer across all cloud providers, is what we've seen. And so you can use the features of Kubernetes to really drive some security.
Cool. All right. Sorry, and I interrupted you. I'm just going to check this. We talked about this one. Okay.
Cool. Keep the questions coming. Great questions.
Oh, we got some good questions.
So on the slim down your images, right?
Sorry. There's one more question. You talked about like staying current, using patches to stay secure. This person is saying, I need to download and install all my software components offline. I can't have internet access. So in that case, how do you manage patches and upgrades? We have to do this for our Fed clients a lot.
Yeah, so
it is a challenge.
Yeah, it's a challenge, right? And so for us, it's about building tooling that helps people, receive those patches and upgrades, and giving them ways through the platform to upgrade them or update them. We have a part of our platform that changes pretty frequently, and what we'll do is you can take the main UI and upload something, and then that will be spread throughout the system. So that's a little bit easier of an injection point. But when you need to install all software components offline, I think that, you can create a base image that is like a lot larger, right? Kind of contrary to what I'm saying here. You can create one that's a lot larger, and then each individual component can slim it down after that, right? So that you have one that generally will provide all the packages that you need. And then each individual application should really make sure that it's only using a subset of those packages and then removing the other ones. That's a tough challenge, especially in offline environments or air-gapped environments.
But we can talk to you offline too to give you more color. We do a lot of stuff with DoD agencies, and they all have to run this way. And so we have a run book for best practices. There's another question, I don't know if you're going to touch on this later, that we talked about network segmentation. And this person's asking whether it's a best practice to have Kubernetes masters segmented from worker nodes on like L2, L3 ACLs to restrict access.
I'll be completely honest, I can't really speak to that.
Okay.
I'm not sure. I think
we can follow up.
Yeah, I mean, like Kubernetes still needs to work, so you have to be pretty careful there. But the more you can scope down access, I think is the better, right? And so it depends on your use cases. Depends if pods are accessing the master API server and stuff like that. So I mean, that's one of the things where you really want to track that traffic and see. You don't want to turn on an ACL or a firewall rule and then suddenly someone's application stops working and you're trying to figure out why. So
first, do no harm.
Yeah, I mean, so a new cluster ground up, yeah, give it a shot, and we would love to follow up. I'd love to hear your use case there and what you're trying to do.
Hey guys, I need to move us along because we're at 19 minutes before the hour. And I know, Connor, you still have a demo and everything, and we do have a lot of great questions. We'll try to get to them, as many as we can.
Awesome. Cool, yeah, I'll speed along here. How do you debug when you slim down your images and you remove package managers and network utilities and you can't look up DNS anymore? Something that's coming, I'm really excited about, ephemeral containers. It's alpha as of 1.16. Use them with caution. Don't use them in production. Kubernetes will say that everywhere. But basically the idea is that it allows binding of a new container to an existing pod to facilitate the execution of debugging commands. So, and in network utilities. So you can use a different image that maybe has all these utilities in it, but it's not part of your core application. And then you can kind of bind it to the same namespace and to a pod that already exists, and you can run network utilities. So this isn't quite here yet. Don't do this yet, but it's something really to watch and look out for, because I think it'll really help users be able to debug their pods without having to bundle all of this other debugging material inside. And so from an attacking and like an attacker standpoint, those utilities are the bread and butter of any attacker. So removing them is a huge win from our perspective. Awesome. So now I'll jump into the demo and I'll talk less. And so the first thing I want to touch on are the configurations we're going to explore. We're going to talk about read-only root file system, which I love, Linux capabilities, which not a lot of people use, and network policies. And I'll show you an example of the network policies that I was talking about. So read-only file system is exactly what it sounds like. Basically, you can make your entire container file system read-only. This is definitely something you could almost never do in VMs. There's too much going on there, too much overhead. And then your entire file system becomes read-only, but you can still mount volumes, right? So it's not, if I write one file, I can't make my file system read-only. It's as long as you say what you want to make read-write, you can make everything else read-only. This is super important when it comes to attackers. A lot of scripts will dump things in /temp or in slash, because in /temp, that's typically read-write in almost every file system, right? There's a ton of applications that rely on it. There's a ton of different OS services that rely on stuff like that. And so in your container though, right, you might be running one application, you can totally make it read-only. So I'll jump in here and I'll walk through an attacker flow here, which is from the Apache Struts vulnerability, the one that lost my and a lot of people's social security numbers, which is unfortunate.
Mine too.
So I launched a pod here. It's Apache Struts. We'll go ahead and exploit it. We won't be doing anything nefarious here. This is a common attack that we've seen, which is people will access Kubernetes API servers and drop minor D or other utilities and mine cryptocurrency. So they're really stealing your resources and unfortunately not your data, but it's still an issue. So in this container now we have minor D running, and what I'll go ahead and apply for you is I made this volume here, user local Tomcat, I made it read-write by specifying it in the Docker file. And I'll make the rest of the application read-only. And then we'll go ahead and rerun the attack. Up. And we'll see what happens. So in this case, right, basically, they just tried to dump minor d and slash, and now we've rejected it, right? So this is a pretty simple change. I changed one line in a Docker file, and now I've stopped a potential attack. For example, /temp in this file system is also read-only. So a lot of the Metasploit attacks would fail against this container as well. So that's just a super quick example of a read-only file system and how it can stop a specific attack. The most important question is, can my app be read-only, and what paths need to be read-write? So if you wrote your app, it's probably pretty straightforward. You probably know more or less where you write. If you didn't write your app, and maybe you're just using an out-of-the-box Nginx, where does Nginx write? So I love this Docker diff tool, to use it in isolation and say, okay, where are we writing? And run secrets, this is Kubernetes, don't need to worry about that, but you definitely need to look at, var cache Nginx, creates a bunch of temporary files for Nginx. So if you make the volume at var cache Nginx, for example, then that will be read-write and, /run Nginx PID. Maybe you can move where that file lives and consolidate it, or maybe you need to make /run read-write. But in general, you're not having slash or /temp be read-write. So in this case, you can really increase your security of your Nginx deployment by doing something like this. Awesome. Now I'll jump into Linux capabilities. I'm running out of time here. The idea of Linux capabilities are you want to split the root superpowers into a series of capabilities. Basically, root could do everything, right? And so what you want to do is kind of try to slim those down. And so you get these kind of logical capabilities like changing ownership of a file, changing permissions of a file, or binding raw sockets, which most of us never do. It is used by ping, for example. And so what I ended up doing on my Tomcat server, I don't have any code for you today, but I used an eBPF probe written by Brendan Gregg. And what we did is we looked at a syscall called cap-capable. And what I could see when I ran the exploit against my container is that the tar command that the minor d is trying to be unpacked by is actually using these commands, or these Linux capabilities. And so what I want to do is I want to drop those Linux capabilities. So I have an example here. You can specify this inside. Okay. Right. You can specify it here at the bottom. In security context of a deployment, you can drop all Linux capabilities. The Tomcat server doesn't use any. I can replace the capabilities of my current running service, and we'll see how the attack fails this time. I think I have this up and running again, and I'll rerun the exploit. Cool. So in this case, what you can see is that we were able to download the minor d binary. We tried to unpack it, and it ended up failing because we couldn't change the ownership of the file. And so this is just an example of, at a very low level in the kernel, how basically we are rejecting what the process is trying to do. And we didn't have to remove binaries or anything like that, but we just blanket rejected all of these operations. So that's just one example of how Linux capabilities and slimming them down, can stop a wide variety of attacks that may come from, you have no idea where it's going to come, but you know that you don't change ownership of files, for example. And it's like a huge breadth of Linux capabilities that you can use.
And just so the folks on the phone who are kind of coming up to speed on some of this stuff and who may feel like, oh, I don't know how to do all of that. I mean, one thing to put a fine point on it here, these kinds of understandings of what is risky and what you don't want to have in your environment are some of the kinds of things that we build into the StackRox platform, for example. That's an out-of-the-box policy that finds things and flags them. We won't automatically stop anything because, first do no harm, don't break the app. But we will alert on them right out of the box. And so we'll help you find these things and identify these kind of unlocked doors and unlocked windows that are a path in for an attacker, flag them for you, and make a recommendation about what could be different. And then once you've decided to lock that down, all subsequent builds would follow that policy, right? So you can choose to enable enforcement, and then anything running would get stopped from having it that way, and anything you go to build in the future wouldn't get built that way. And so we take Connor's brain and we turn it into out-of-the-box policies that sit in the software and help you find and stop these things from happening in your environment.
Sounds like
it can look overwhelming.
That's the thing too, is you want to kind of demystify some of these things, right? Linux capabilities, it's something that exists in operating systems that everyone's used, but we've never really come into contact with them, right? And like before I got into containers, I never had heard of Linux capabilities. And so there's kind of a huge learning curve there. And what I want to do is flatten that learning curve. And so you don't really need to know too much about this, but we can give you recommendations about how you can, lower your attack surface. I think that would be a huge win overall. So I'll jump into the final demo example here, which is network policies. I'll explain, this YAML is sort of intimidating, which is why I don't love it. But basically what this network policy is saying is that you have a pod selector, which is which pod does this network policy apply to. It applies to anything that has the label app and the value web. Then it's saying, what can I accept connections from? In this case, I'm saying this namespace, anything that has team operations, so anything from the operations team that has a label monitoring, right? So maybe you're thinking about using Prometheus, and that's a scrape model. And so you need to allow Prometheus to have access to your application to scrape metrics, like the metrics endpoint. You can scope this down more to ports. You can do IP ranges. There's a lot of options in network policies. But basically that's what this example does. And I'll show you what it looks like in the app here. I'm going to apply a deny egress network policy. I have an API server. It's serving requests. It is not sending outbound connections and should not send outbound connections. And so I'll apply this default deny policy here, kind of as simple as that, and I'll rerun the exploit. What's going to happen on this, move it up to the top here. What's going to happen in this example is that wget is basically going to hang. So the traffic to egress is basically black hole. Wget will hang, and we aren't able to download the crypto miner because the egress policy is blocking all the outbound connections. And so there's some of these large blanket policies that you can use to really help defend against, generic attacks like, your database should not reach out to the internet. So let's just make sure your database doesn't. And you can kind of build that in from a firewalling perspective. The last thing to remember is that security is hard. We've given you a lot of information today. We've shown you a lot of examples of risk in your environment. And I don't want everyone to think that you have to do all of it, right? Even the 3 examples I showed you in the demo, all 3 of those stopped the same attack, right? And so picking and choosing which ones are right for your organization, picking and choosing which ones you feel like you can operationalize and you can get developers behind, is that, action is better than non-action. And so, really work with your teams to make sure that you are driving the right thing home. And with that, I'll answer more of your questions. You can email me. You can go to our website. We got a lot of the domain-specific knowledge. We're here to help everyone.
Those of you coming into the community of Kubernetes more recently, it's one of the most satisfying things about this community is that it's a very welcoming and helpful community. So you're going to find that everywhere you turn. People want to help people do the right thing and learn and do things better and faster. So definitely a pay it forward kind of place. And we're excited to work with anybody who's on that learning curve and help you. We did have one question. It might be a little bit orthogonal, but I'm curious your take. They're asking, how can I take security actions when I use Helm in my production environment?
So first things first, move to Helm 3, get rid of Tiller. That is a huge win from a security perspective to move to the newest version. Doesn't run as cluster admin within your cluster. I think that's the first and foremost thing to do. And then next, from a Kubernetes perspective, we're looking at Helm is a way to deploy objects into your environment. You can validate some of those objects before they get sent. You could look at, you could do some static analysis of the deployment YAMLs that get rendered and make sure that they're complying, right? And maybe pre-scan the images that people are running with Helm, right? And then at the end of the day, Helm just deploys it into your cluster, and so you can still provide protections at deploy time, admission controllers or other policies to really highlight anything that may be going wrong when people are deploying via Helm. And so it's kind of like a layered approach there, right? It's try to look at things statically if possible, or you can look at things at deploy time, or even once they've been deployed and look back and say, what policies of my organization are currently being violated.
Awesome.
Guys, well, we've got a little time. Michelle, I think we did get to most of the questions here, though, which is great. I just have some more housekeeping. You know, we always give out 3 Amazon $50 gift cards to attendees. We don't announce it till the end, so you have to kind of wait. But our 3 winners today are Alan Stubbs. He spells his name the way I do, so good reason. Mary Pan and Ben Rothke. So the 3 of you, our staff will contact you and mail you your Amazon gift card and use it well. Maybe on like a good Kubernetes book. That's a great last question to end this. Connor, if they have $50 to spend on some Kubernetes books, where should they spend it?
Oh man, I spend most of my days in the API docs. I don't know what book I would recommend.
We can follow up on that front. We do have a question that's come in around how the licensing model works. And so for StackRox, we are self-contained software that runs wherever your infrastructure runs. So if that's in the cloud, we run in the cloud. If it's prem, we run on-prem. No SaaS component, so we're not holding your data. And we license by the node. So we deploy just like a kube app. And it's a set of containers and a daemon set per node, and it's just licensed by the node.
Yeah, and I think something to say here too, if I might jump in, is that like, you know, we understand like the reality of a cloud native stack, right? Like you auto scale, right? If you're an e-commerce business around Christmas time, you're going to have more nodes, right? And so we always try to work and understand those needs as well, because you know, kind of doing it naively in a cloud native way is not exactly what we're going for. So.
Yeah.
I think that's just something to think about. And
we're flexible.
Yeah, exactly. I think, you know, scaling is a reality. Like people use Kubernetes to scale, and so like we're not going to work against you in those regards. I think
it's a very good.
It's a fun take actually, because I've seen some interesting stuff there. So
sure, things can change quickly.
All right, we've got the follow-up. If anyone has a question or comment, or you want to reach out to StackRox, Connor's nice enough to give you his email there, and of course you can go to stackrocks.com. They're also hiring. Who isn't hiring these days? Before we say good day and good weekend to everyone, I do want to remind everyone, if you are going to RSA conference next week, StackRox will be there. Michelle, you don't know what booth you guys are, do you?
I do know. I should know. And it's 3106. For those of you familiar with Moscone, there's a North Hall and a South Hall, and we're in the bridge between, close to the North Hall.
Excellent. Connor, I got to give a special thank you to you for allowing Michelle and I to kind of hijack you like this. He didn't know when he got on that Michelle and I were doing this with him. And I know you thought you were going to finish in plenty of time, but I've never finished a webinar in plenty of time. So thank you very much for being a good sport and letting us partake in this with you. I hope everyone out there had a great time. It's a great way to spend your Friday. You know, Kubernetes is becoming the very dominant form of compute. And if you want to excel in this industry, you're going to have to learn Kubernetes. And if you're going to learn Kubernetes, you better do it securely. So thank you very much, everyone. Alan Schimmel for MediaOps, DevOps.com, Container Journal, Security Boulevard. Thank you to our friends at StackRox, Connor and Michelle. Have a great day, and we'll see you soon on another webinar. Bye-bye.
Awesome. Thanks, everyone.
Bye.